NCBM 0324, Section 1.3, Slope Formula and Graphing Linear Equations in Slope-Intercept Form, Part 4. So we have this slope-intercept form, y equals mx plus b. How can we use that now to, instead of writing the equation, how can we take the equation and get the graph, right? Let's get the picture from the information on the equation. Well, the m and the b mean something, right? The m is the slope, the y-intercept is the b value. So that kind of gives us a starting place to make the graph, and the slope kind of builds the rest of it. So the first option we can take when we're graphing y equals mx plus b. So just a reminder, mx plus b. That's the way the equations should look if I'm going to use this first method. Where we can plot the only given point, which happens to be the y-intercept. So whatever the b value is, I know one of my points on that graph is going to be 0, b. Right, let's use it in the other direction. That information can go in the other direction as well. So from this number, whatever is being added or maybe subtracted, maybe the b value is negative, we're going to make that into the ordered pair 0, b. Then we're going to follow the instructions found in the slope. We're going to apply the rise over the run to determine the second point of the line. So from this starting point, I gotta think of it as our starting point, I'm going to apply rise over run. Sometimes it's up, sometimes it's down, sometimes it's right, sometimes it's left, but I'm going to use those directions to find a second point. And really, all we need are 2 points in order to graph a line. So once we have that second point plotted on our Cartesian plane, we're going to connect them and get our picture. Let's try that first method. Let's look at A. We want to graph the following linear equations in example 4a. I have y is equal to 3x minus 4. Y is equal to 3x minus 4. So the information, is this in slope-intercept form? Is it in mx plus b form? Yes, and I know that not only because it's 3 times x minus 4, but that y is by itself. Remember we said the slope-intercept has that y equals on its own. So I'm going to need, in my option 1, my y-intercept. So my b value in my equation here looks to be this minus 4. So that means as an ordered pair, I'm going to graph 0, negative 4. Then I'm going to need my slope. Remember, this is the m value. In fact, why don't we write that? Let's write m is equal to rise over the run. Okay, and over here, my m value is 3. But my m should have a rise and a run. In front of the x is just the 3. That's the m spot. It's only a 3. Where's the fraction in that? But it's a whole number. I can make any whole number into a fraction by putting it over 1. And then we can use, and we can see, our rise over run. Okay, so we have everything we need to graph. We have our y-intercept, we have our slope. So over here, I'm going to graph my y-intercept first. That's the step 1. So I'm going to go along my y-axis, 1, 2, 3, 4. And then to get a second point, I'm going to use my slope, my rise over my run. Both rise and run are positive, so I'm going to go up and then to the right. So rise 3, 1, 2, 3, and then to the right 1. And I can connect these and be done and get my graph. I could also continue on if I wanted to. I could go up 1, 2, 3, 1, right? Apply my slope to find a third point, or maybe a fourth point, right? If I had a little more room, I can find a fifth point. As long as you have 2 points, you can make the graph. connecting those points with a straight line, I get the graph of my equation. So a really nice method of graphing these linear equations if it's already in that y equals mx plus b form. Let's try the next one, B. And maybe now let's look at the second option for graphing linear equations. So in my second option, my second possibility for graphing is to simply make a table. That's really what it's going to boil down to. And when we say make a table, we're going to pick at least two values for x. We could pick more if we wanted to. But if we pick two values for x, we're going to follow the order of operations to determine the corresponding y values. So we'll make a table where we have some x's, and the y value, we're going to use whatever numbers we pick in here, the numbers we choose here, and we're going to plug into the equation to find the y's, right? We're going to figure out what are the y values that match those x's. And then we graph, and we have our picture. Let's try that, in fact, on part B. So making a table of values. Instead of using rise and run, we're just going to pick some x's and figure out the y's that match. On B, we have y is equal to negative 2/3 x minus 1. Negative 2/3 x minus 1. So a table of values, we said. We're going to use that method. I'll go ahead and draw it down here. So we're going to pick some x's, and to find the y value, I'm going to plug it into this part of my equation. The y is going to equal to negative 2/3 times whatever x we choose minus 1. So we made our table. We're going to pick two values for x. I could pick more, but 2 is all I really need. Now, considering my fraction, I'm going to be a little bit strategic in the x value that I choose. I'm going to go ahead and go with maybe a negative 3 and a positive 3, just to make the fraction calculation a little nicer. So for the negative 3, I'm going to plug that into this x spot of my y equals equation. So the y value is going to equal to negative 2/3 times a negative 3, that's the one we chose over here, minus 1. And we're evaluating, so we're finding a number, order of operations. Looking at my multiplication first, negative times a negative will be a positive. And then this negative 3 can be written as negative 3 over 1. Okay, so it's positive. The 3 here and the 3 here can reduce down, leaving behind simply a 2. Minus 1, which will give me 1. So as an ordered pair, I'm going to plot the point negative 3, comma 1. I can go ahead and put that on my graph. Negative 3, comma 1. Up here. Let's do the same thing for the positive 3. So negative 2/3 times a positive 3. Write that as 3 over 1. Even if you multiply straight across, you would get negative 6 divided by 3. Well, that's a negative 2. Still has that minus 1. Minus 1. And negative 2 minus 1 is a negative 3. So now my second ordered pair I can use to graph the line is 3, comma, negative 3. 3, comma, negative 3. And connecting those 2 points with a straight line, we get our graph. So either way, we get the same picture, even if I had done the slope and the y-intercept with this second graph, we still would have had the same image, right? The same graph overall, no matter how you find it. It's good to have options. Sometimes the table goes a lot faster, believe it or not, than the slope-intercept form. A lot of times slope-intercept form is the faster way, but it's still good to know both options.